All right, so let's go to the bright space. We're going to go to Chem 121 lab. The lab we're looking at is called calorimetry. Contents. Chem 121 lab. And we're going to scroll down till we see calorimetry specific heat lab. And you guys should see Chem 121 calorimetry student version PDF. Let's just click on that. And then give me a thumbs up once you have it up, guys. It looks like this. Okay, most of us have it up. If you scroll down, or even if you download it, you guys will see there's a link on the second page. And the link on that second page, let's go ahead and click on this link. Let me pull it up as well. And then I'm going to share my screen with you. All right, everybody got the link up? Give me a thumbs up if you have the link up. All right. We're gonna click on experiment on the link. So you see the 3 tabs at the top that says overview, learning outcomes, and then experiment. We're gonna click on experiment. And we're just gonna skip right to run experiment. All right, so in this experiment, I'm about to share my screen. Once I can pop it back up again. All right, everybody got the link pulled up. Hopefully there's no block up, no pop-up block-ups or anything like that. Thumbs up if you got the link pulled up. All right, most of us got it. Okay, great. So let me go ahead and share my screen. All right, so this is the page we should be on, where it says experiment. We've run the experiment. I'm gonna go ahead and you guys pull up the lab procedure right next to it. I'm on page 2, which says 17. And actually, I'm gonna go to page 18. Let's go to page 18, where you have your first data table. So you should see your first data table, and it says part A, heat transfer from metal and water. So all we're doing in this lab, guys, is we're gonna run this simulation. We're gonna follow the steps step by step. I'm gonna go through the first part with you, but when you go to do this on your own, I need you guys to read the procedures, steps 1 through 6 on the first table, and all the steps. You need to read the procedure carefully, because every answer that you need is gonna be in the procedure. So first off, let me explain what we're doing. We are measuring the heat transfer from one substance to another. And that is what calorimetry is. Okay, that's all the word calorimetry means. We're just measuring the amount of heat transferred. So remember, we talked about the law of conservation of energy, which says that energy is neither created nor destroyed. Remember, this is what's happening. Energy is not going to be created nor destroyed. We're just transferring it from one substance to another. That's why we can say it's either positive or negative, because if it's positive, that means it's going into a substance. If it's negative, that means it's going out of a substance. So it's still just saying we're going from one substance to another, and that's just in our entire universe. We are transferring energy all the time. So one way to measure how much energy that's being transferred is we're going to use calorimetry. And this metal piece right here, this big metal device right here is called a calorimeter. And it just measures the amount of heat transferred. So in our first setup, what we're trying to do is we're going to take a piece of hot metal and we're going to heat up the hot metal, and then we are going to transfer it to this calorimeter and measure the temperature change. That's all we're doing. Okay, so if we look at our procedure, hopefully you guys can pull up your procedure on a different screen, or if you have it pulled up, print it out. The first step says beneath the beaker and hot plate. Here, let me see if I can pull mine up at the same time. Okay, so this is the page I'm on. It says beneath, this is where I am, beneath the beaker and hot plate, click on solids tab and select aluminum. So that's my first step. That's what I'm gonna do first. Let me get back to it. So I'm saying I'm going right here, I'm clicking solids, and then I'm gonna scroll to aluminum. All right, so that's my first step. The second step says, let's adjust the mass to 20 grams and adjust the temperature to 200 degrees Celsius. So it says right here, this is my mass. I'm gonna move this little tab over to where it says 20 grams, sorry guys. It's saying 20 grams. And then I'm gonna move this tab over to where it says 200 degrees Celsius. All right, so then the third step says click the next button. Click the next button on the left frame. I'm gonna click this next. And then the fourth step says, now click on the liquids beneath the calorimeter. So this is the calorimeter right here. I'm gonna click on liquids right now. When I click on this liquids, it says, I want to go to water now. So the only two options it gives me is either water or ethanol. Right now I'm gonna click water. In this class, we're gonna click water. And it says I want 100 grams of water. Step 4, it says move it over to 100 grams and adjust the temperature to 20 degrees Celsius. It's already at 20. I'm gonna go ahead and say show specific heat here for me. Okay, all right. So it says, now record the initial conditions in table 1. So it's saying if I go back to my table, I'm gonna go back to the table here where it says record the initial conditions in table 1. My initial conditions, we just put it all down. For mass of the aluminum, it's 20 grams. For mass of the water, can anyone tell me what the mass of the water is?
100.
It's 100 grams. The initial temperature of the aluminum, is 200 degrees Celsius. That's what we set it at. The initial temperature of the water is going to be 20 degrees Celsius. Now, when we get to the final temperature of the aluminum, we're going to have to figure out what that is once we hit the start button. So let's go back to the tab. We don't know what the final temperature is. So it's basically saying, imagine I took a piece of aluminum and I heated it up to 200 degrees Celsius, which is really hot. Remember, 100 degrees Celsius boils water. So 200 degrees Celsius is really hot. I then transferred it to this container of water. It's 100 grams of water in this container right here that's set at about room temperature, which is 20 degrees Celsius. So I took a really hot substance, put it in room temperature water. It's gonna transfer some of its heat to the water. That's what we're trying to figure out. So the thing says, we're gonna click on start. Where'd I go? Let me hit next. I wanna show my graph view and show microscopic view. So basically I just wanna show what is happening. Let me make this big. And then I'm gonna hit start, guys. So it's saying I took my hot metal, I put it in there, I closed it. I let the heat of the hot metal transfer to the water, and I'm seeing the temperature of the water increase. If you look at this table, at this graph here, we see in gray, that's the aluminum. We see in black that that's the water. So the temperature of the aluminum started off really high. The temperature of the water started off really low. They then came to the same number. That same number is 27.45. So what I'm saying now is that my final temperature for the aluminum and my final temperature for the water is the same thing. So right here where it says final temperature in this block, what are we going to write, guys, for both of the blocks?
27.45 degrees Celsius.
We're going to write the 27.45 degrees Celsius for both of these. The final temperature is the same. The final temperature is the same because the amount of heat that left the aluminum got transferred to the water. And so their overall amount of energy that's either being absorbed or released is going to be the same number. So then we can go about the steps. We can calculate the change in temperature for the metal because we know it's the final minus the initial. We can do the same thing for the water. It's the final minus the initial. And then further it says in the space, show all calculations. If you just show me one of the calculations, like I said, like for the aluminum, I'm satisfied with that. Okay. We're going to answer these questions. Observation is basically saying, what do you see happening? Record the final conditions of aluminum and the water in the table above. You're just saying, write down what you saw that happened. You guys might have seen that the temperature of the aluminum decreased dramatically and the temperature of the water increased just a little bit, but it still increased until they equaled the same thing. All right, so we're going to answer those questions. We're then going to draw out the graph that you see on the screen. And then it says the part A, which substance, aluminum or water, loses heat when they are combined? You guys got to think about those answers and try to come up with the answer together. We're basically going to answer all these questions. When we get to number 4, it says calculate the heat transferred to or from aluminum. Use the equation. So we know the mass of the aluminum is 20 grams. We know the specific heat capacity of the aluminum because if we go back to our table, we clicked here that says show specific heat. So we know the specific heat of the aluminum, which is the 0.903. We know the change in temperature because we wrote it down in our table. So we should easily be able to calculate the amount of heat that was either absorbed or given off by the aluminum. So then we have to calculate the heat transferred to or from water. We're going to use the specific heat of water and do the same thing. Compare the two answers and then answer these questions down here. So that's part A. So I've pretty much told you guys how to do part A. Now it's just kind of like answering the questions and filling in the answers. Part B, you're going to do the same thing. It says repeat the experiment using the unknown metal and record the data. So now we're going to do the same experiment. I'm going to hit reset to do the same experiment. But now when we do the same experiment, when we click on solids, we want to click on unknown metal 1 for part B. That's all that means. So we're still going to do the same thing. We're going to say 20 grams of this unknown metal. We're going to set it to 200 degrees Celsius. We're then going to click on the water. We're going to say 100 grams of the water. We're gonna set it to 20 degrees Celsius, run the same experiment and see what numbers we get. And then we still have to calculate the change in temperature, the specific heat, the heat. And then this is a reference table. Once we calculate the specific heat capacity of our unknown metal, our ultimate goal is to figure out what our unknown metal is. So just in case you're unclear, our unknown metal is not going to be water. It's going to be one of these metals. We have to figure out which metal it is just by doing our calculation and solving for C and then matching it up here. So if it doesn't match up exactly, that's fine. You probably have your sig figs a little off, but that's fine. We're going to go to the closest number that we see, and then we're going to write it down. So then you have to answer the questions for part B. When you get here that says calculate a percent error, calculating the percent error for number 3 here, you're going to use this formula, which says reference value of specific heat. The reference value of the specific heat is from this table. This is the reference value. Okay, so let's say you think your unknown metal is iron. The reference value for iron will be 0.444 joules per gram degree Celsius. The experimental value that you would write down for iron is the one that you wrote down in your table. So meaning the one that you calculated here for your unknown metal. Okay, and then we're gonna subtract those two and then divide it again by the reference value, which would be 0.444. All right, so we're gonna answer that. And then, yeah, you guys should be able to, let's go ahead and do, let's not do number 7, but we can go all the way to number 6. All right, so let's answer part B all the way through number 6, and then we can talk about number 7 at a separate time. And then that's it, guys. So let me know if you guys have any questions right now.
You know how it says in the space below?
Yeah, so I want you to show your work just like the last lab, meaning just do one like basically depending on the question. So under the table, you just have to show one calculation. But on the other questions, like the part A and part B questions, if they're asking you to solve for something, yes, I want you to show your work. There is under assessments and assignments again, remember we're gonna upload our lab. We're gonna write our names on our labs as well as our partner's name, and we're gonna put it as the title of our lab. Whoever has the, the best way to upload it, whether it's a scanner or whether it's an iPad or whether it's just even taking a picture and uploading it, we're gonna do that. Make sure you write you and your partner's name on it. And it goes under assignments. It already has an assignment there that says Calorimetry Specific Heat Lab, and then we're just gonna upload it there. Any other questions?
How much time do we have?
You have, I mean, it's 10 o'clock, it's 10:10 right now. So if you guys want to take a quick break, I understand that. Let me stop the